Okay, good morning. So today we're looking at exercise 14, dealing with calculus on page 181, namely optimization. Okay, so let's start. Number 1. Unless otherwise stated, give all answers correct to 2 decimal places. State the answer to all calculations involving pi in terms of pi, as well as correct to 2 decimal places. Do not round off your answers until the end. Okay, so you must use the answer button or pi in its original state till the end. Okay, so in number 1 we are told that the right cylinder has a volume of 2 liters. Okay, so we know that when we're talking about dimensions, we talk about either centimeters or meters or so on. So the conversion between liters and milliliter and centimeters, we know that 1 centimeter cubed is equal to 1 milliliter. Okay, so 2000 milliliters has to be 2000 centimeters cubed. Okay, where did I get the 2000 from? So there's 2000 milliliters in 1 liter, 2000 milliliters in 2 liters, and 1000 milliliters in 1 liter. Sorry, I made a mistake there. Then we are told determine the dimensions of the cylinder for which the total surface area will be a minimum. Determine the dimensions of the cylinder for which the total surface area will be a minimum. So for the total surface area, we know that's going to be perimeter of base times height plus 2 area of base. Okay, so if we're looking at the cylinder, okay, that is your radius and that's your height. Alright, so to look at the perimeter of the space, it's going to be 2 pi r, which is fine. My height is h, but you see that now I'm going to have 2 unknowns in that formula, which is going to be a problem when I'm going to start differentiating. I must only have 1 unknown, okay, or 1 value I'm going to differentiate from with. So I'm going to write h now in terms of r. Okay, we're going to write h in terms of r. How are we going to do that? Basically, we need to work with what is given. We know the volume is 2000 centimeters cubed. But how do we calculate volume? Volume is going to be area of base times height. You see where the height is coming in again. So the volume is going to be 2000 equals area of base, area of a circle. It's going to be pi r squared, height. How do we get height on its own? Divided by pi r squared both sides. So the height is equal to 2000 over pi r squared. That's now your height. Okay? So we say, okay, the total surface area, TSA, total surface area equals perimeter of this base. How do you calculate the perimeter of a circle? 2 pi r times height plus 2 area of base, so it's pi r squared. So what we're going to do now is we're going to replace h with 2000 over pi r squared. So total surface area is equal to 2 pi r times 2000 over pi r squared plus 2 pi r squared. Can I apply the derivative as it's standing there? No. Simplify more. So of course that cancels. Okay. That's going to give you 4000 over r, because of that, plus 2 pi r squared. Okay. Remember the question says that determine the dimensions. Dimensions are the lengths or the sizes of the cylinder for which the total surface area is a minimum. So when they say minimum or maximum, we apply the first derivative. So let's apply the first derivative. Firstly, I need to get it in the form of ax to the n. We need to get it in that form. As you can see, this is not in that form. So the total surface area is equal to 4000 r minus 1 plus 2 pi r squared. Okay? So we apply the derivative. So d of TSA, the derivative of the total surface area with respect to r, is equal to negative 4000 r minus 2 plus 2 times 4 is 4. 2 times 2 is 4 pi r. Okay. So what we do is, at the maximum minimum, the first derivative is equal to 0. So I set it equal to 0. I can drop that. So it's going to be negative 4,000 over r squared is equal to 4 pi r in the negative over 1. Cross multiply. So it's going to give you 4 in the negative 4 pi r cubed is equal to negative 4,000. Okay. So to get r cube on its own, it's going to now be 1,000 over pi. And to get r on its own, it's going to get the cube root of 1,000 over pi, or 10 over the cube root of pi. It's the same thing. Okay. But now, let's just see, unless otherwise stated, give all answers correct to 2 decimal places. State answers to all calculations involving pi in terms of pi, as well as, so there is in terms of pi. Okay, so now we must write it in 2 decimal places. Okay, so we're going to have this as, let's put this up a bit. It's going to be the cube root of 1,000 over pi. Yes, pi shift gives us 6,83. So that's 6,83. So your radius is 6,83 centimeters, of course. Alright. Dimensions includes, of course, the height. So therefore the height, which is 2,000. So it will be 2,000 over pi radius, which is 6,83 squared. Okay. So of course I can put it in the calculator. It's going to be 2,000 over pi times answer squared. It's going to be 13,66 centimeters. Okay. So now, okay, the next question says calculate the minimum surface area of the cylinder. Now the minimum surface area occurs with the minimum value of r. Okay. If I had made any mistakes, you can contact me on that number, or if there's an easier way on explaining something, or ever must explain or misunderstood, you can give me a call on that number. Otherwise, this video is off free. Okay. Going back to number 2. So 1.2. The minimum surface area, so total surface area, of course, is going to be, we work it out to be 4,000 over r, which is 6,83. I'm using this formula here, in case you're wondering where is this coming from. I'm using this formula. Why am I using that formula? Because that is, this total surface area represents the total surface area for this cylinder in terms of r. I could have used this here as well. Where's this now? Total surface area. Yeah, I could have used that formula as well, because I have a h, but I'm just going to use that since there's one value I'll be substituting in. So that is going to be 4,000 over r plus 2 pi 6,83 squared. So I'll work that out. So it's 4,000 over 6,83 plus 2 pi times 6,83 squared. That gives you 8.76 centimeters.